Artificial intelligence requires a massive amount of computing power, and all those relentless calculations generate severe equipment-melting heat. It seems like there's an obvious fix. Why not just take those server racks and drop them in the coldest place on Earth to take advantage of the freezing air? The sub-zero temperatures would certainly keep the hardware chilled, lowering the cooling load. But keeping a server cold is only half the equation. You still need an enormous amount of raw electricity just to run the processors. In reality, every functioning data center relies on 4 non-negotiable pillars to survive: cheap power, ultra-fast internet links, accessible maintenance, and legal permission. And despite having the perfect climate, the Antarctic continent entirely lacks all 4 of these essential lifelines. Let's start with power. Look closely at this sprawling research outpost. You won't see connections to a normal commercial power grid because there isn't one. Instead, almost every facility operating down here survives entirely on diesel fuel shipped in from the outside world. Agencies like the Australian Antarctic Program point out that transporting thousands of gallons of heavy fuel across volatile oceans and navigating through dense sea ice is incredibly expensive and highly dangerous. You can't easily bypass this by building a localized nuclear plant, and standard renewable infrastructure fails here too. The extreme conditions quickly encase wind turbines and solar panels in solid, immobilizing ice. To power a commercial data center, you would need a relentless, never-ending convoy of fuel ships. The logistical cost would instantly wipe out whatever money you saved on air conditioning. Even if you could generate enough electricity, a server is useless if it can't quickly send its computations to the rest of the planet. This diagram shows how the internet physically functions. These glowing lines are the massive undersea fiber optic cables binding North America, Europe, Asia, and Africa together. But panning down to the South Pole reveals a massive dark void. Antarctica is completely cut off. Right now, bases like the U.S. Antarctic stations have to rely heavily on large satellite dishes just to maintain basic communication. Satellite internet has extremely strict bandwidth limits. It works for sending emails and basic research data, but it would instantly bottleneck the massive, continuous data streams required by a modern AI facility. Without a physical, high-speed tether to the global grid, a multi-billion-dollar server farm essentially becomes an isolated brick. Let's say a major tech company was willing to absorb all of those costs. Imagine they decide to spend billions to build a specialized power plant and lay their own private undersea cable. Even with unlimited funding, the project would immediately hit a hard legal wall. This land is governed by an international coalition under the Antarctic Treaty's Environmental Protocol. This protocol explicitly designates the entire continent as a strict natural reserve, placing heavy restrictions on commercial human activity. Legally, this territory is devoted to peace, conservation, and scientific research. That's why facilities here, like this research base elevated on stilts, are meticulously designed for low environmental impact, not mass industrial scaling. Attempting to break international law and engineer an impossible supply chain just to save money on air conditioning makes no sense. It proves that as much as we talk about the digital cloud, it will always be anchored by the physical limits of human infrastructure.